Hello, I am Dr. Deepthi and we are discussing the subject Physics relevant for artists. When you imagine a sound wave, you might think of something that looks like a water wave, that is, a wave at the beach and so on and so forth. Wave is a transfer of energy without transfer of matter. If you and a friend hold on to both ends of a rope, you can get energy down to the friend simply by moving the rope back and forth. Although the rope has some motion, it isn't actually transferred to the friend. Only the energy is transferred. Energy in a wave is proportional to the square of the amplitude or height of the wave. That means if you compare the energy of a small wave that you might surf on to the tsunami, even though the tsunami is only about 6 times the height, it would have 36 times more energy. Our ears are incredibly awesome receptors for sound waves. The threshold of hearing is somewhere around 1 into 10 raised to minus 12 watts per meter square. Can you just compare this with a 1 watt bulb? Now, when more than one wave is present in the same place, we are still able to hear it and distinguish it. For example, you could be at a symphony and you would be able to make out the sounds of individual instruments while they all play together, and also hear and understand a message being whispered to you at the same time you detect someone coughing 5 rows back. How do the sound waves combine to give you the totality as well as the individuality of each of the sounds in a room? Wave interference. It's intriguing that a lively party with everyone talking at once, you are able to hear the totality of the noise in the room and then alternatively distinguish and concentrate on the conversation of one person. That is because of an interesting phenomenon of waves called superposition. Wave superpositions occur when two or more waves move through the same speed in a wave medium together. There are two important aspects of this wave superposition. One is that each wave maintains its own identity and is unaffected by any other waves in the same space. This is why you can pick out an individual conversation among all the voices in the region of your car, in the region of your ear. The second aspect is that when two or more waves are in the same medium, the overall amplitude at any point on the medium is simply the sum of the individual wave amplitudes at that point. When two wave pulses move towards each other, they can reach the same spot in the medium, and then the combined amplitude is just the sum of the two. But if the two wave pulses are moving away from each other, then the scenario is different. When it comes to music, the idea of interference is exceptionally important.